So right now I'm going to write a program to create a binary search tree. Um, it's actually yeah. So basically the binary tree has two nodes, and the property of binary search tree is if you have a if you if you have a node and the right subtree is lesser than the root, and the left subtree is the right subtree is greater than the root and the left subtree is lesser than the root. That's the property of binary search tree. So it's going to be a basic C code to create a binary search tree, and then printing the binary search tree. That's what I'm going to write today. Let's see how quick I could write this C program and complete this basic program. First, I will include the header files stdio.h, and we also need include stdlib.h. And let's first have the main function and return for the main function, return 0. And now I will define the structure for the binary search tree. Name is bst node, int data, struct bst node star right. This is a pointer to the right subtree. Struct bst node star left. This is pointer to the left subtree. Finish the structure. Let's have the root, struct node star root. First it's going to be null declared. This is not a node, this has to be bst node. Okay, yeah, maybe to be better to understand, we can just keep it as a node, so it's easy. We also know the bst node. Okay, right. Now let's first write out make it a point like what we are exactly going to accomplish. Okay, so first create a bst tree. Okay, implement insert function, implement get new node function, implement in order, pre-order, post order functions to print the bst tree. Okay, that's all. And code walkthrough the code, walk through the code, right? Okay, so let's have a integer array values. Let's say, for example, first we are going to insert 50, then we are going to insert 25, then we are going to insert 25, then we are going to insert 15, then we are going to insert maybe 35, then let's insert 20, and then 10, and then 5, okay, and then 0, and this lesser value is going to be on the left side of the subtree, left side of the binary search tree node root, and on the other side let's put 75, and then 75, then maybe 65, then 95, then 60, 70, 80, 100. Okay, let's also write this, have this output here, so we will know how it's going to be inserted. Okay, first first it's going to be the root node is 50. Next element is 25. Okay, and next element is 15, and next element is 35. 35 is lesser than 50, greater than 25, and it will be placed here. And then we are inserting 20. 20 is lesser than 50, lesser than 25, and greater than 15, so it's going to be right here. And then we have 10. 10 is lesser than 50, lesser than 25, and lesser than 15, so 10. And then we have 5, and then we have 5. 5 is going to be lesser than 10, and then we have 0. 0 is going to be lesser than 5. So you will be clear once we have the, you'll be clear once we have all the nodes populated. And now we get the now we have the value 75. 75 is greater than 50, so it's going to be here. Okay, and then the value 65. 65 is greater than 50, lesser than 75, and then we have value 95. Value 95. Okay, let's have it here. Okay, and then we have 60. 60 should be coming here. 60, and then we have value 70. 70 is lesser than 75, greater than 65, so it should be coming here. And then we have 80, which is greater than 75, lesser than 95, so it should come here. And then we have 100, which is greater than 95. Okay, that's all we have right now. Let's make it more clear. Okay, the root node is 50. Maybe we should take out the 5 and 0, but let's have the value so that we will be able to verify the in order, pre-order and post order. Okay, so let's come back down. Okay, let's first go here. Okay, I'm going. Okay, so I will we have the for loop here. I'll have the for loop. I write the for loop int I 0, looping through the array, and I less than int size of the array is size of ARR by size of ARR of 0. Now here less than size I plus plus root equal to insert ARR of I. So what this will do is this will iterate the array one by one and then inserting into the binary search tree. Now the insert function should return the root node. So I'm going to write a function struct node star insert, and let's have I'm going to write a recursive function, so I will have the root node given here as well as input. So here struct node star root int data, and first if the root equal to null for the very first node, what this will do is get the root, get new node, pass the data. I'll first write the get new node here. This will return the root node, so struct node star get new node. This will get the data, so int data, and this will have the struct node star temp get the memory allocated, struct node star malloc struct node size of struct node, size of struct node, and temp data equal to data, temp right equal to temp left equal to null for the new node, and then return once it is created and value is added, returning the node temp. Okay, maybe I'll have this as a name as a new node. That makes a lot of sense, right? Yeah, new node, that makes a lot of that's a meaningful name, new node, that's meaningful. So I'm replacing all the temp with new node and returning the new node. Okay, get the new node, so returning the new node, and this gets the new node. Okay, now root node is created, else if root data greater than data, then this should go to the left. Okay, root left equal to get, call the insert function insert, pass the root left, as we are going to insert on the left, and then the data. Okay, once this is done, let's do the else if root data less than data root data less than the data, then data is bigger than the root, it should go to the right. Root right equal, call the function again as a recursive call, root, pass the right and data, and finally return the root as we have the return root. So this will create the binary node. Now I will have the in order, pass the root, pre-order, in order, post order. Okay, pre-order function, pass the root, post order function, pass the root. Okay, they are not going to return anything, so void pre-order struct node star root if root equal to null, return okay, this is pre-order, so pre-order is right, root, pass the root right, then print f okay, printf %d root data, then call the pre-order root left. Okay, pre-order is getting called. Okay, printf pre-order output of Bst. Okay, printf /n post in order of Bst, output of Bst. And printf /n post order output of Bst. Okay, all right, printf /n end. Okay, fine. Let's have the in order, void in order struct node star root if root equal to null space return in order this is pre-order, so this should come here, delete, here, in order, left, root, pass the left, printf, %d, root, data, okay, in order, root, right. All right, and I'm going to write the post order now. So void post order struct node star root if root equal to null, return post order is the root, left, right, and then the root. So it's going to be post order root left post order root right printf d space comma root data. All right, so let's so it's going to be a long video, but let's go through how it's going to work and see if we miss something on the syntax. I0 I less than size I plus plus. Okay, first I have the integer array, and then I calculate the size of the array and iterating over the array to get each value and then calling the insert function. So this can create the binary search tree with value 19. So I can copy the input right here, so we will know. I'll copy the input here. Okay, so first the value 19 and the root null will be value 50 and the value 50 and root is null. Root null is passed here and the 50 data is 50. If root is null, then I'm going to get a new node with this data. This new node is getting called with value 50. I create a new node within this function and then get the memory allocated for this node, and for this new node's data part I fill the value 50 which is data, and new node's right and new node's left is null, setting it to null and return the new node right here, and then return the root. And next call will be made with value 25 with the root 50. So root 50 comes here and 25 is the data, and root is not null, so it comes here. Root 50 is greater than the 25, so the 25 should go to the left side, calling the insert function with root left which is null here, and data 25 recursively called the insert function again with this one will be root left and 25. The root left is null, and then we create a get new node on the root left, and that will be assigned to the root left, and the root will be printed back. The same way for all the values it will execute. I'll try to run the code and see how it's going to be. Wow, on the first run itself we could go through. So the best way to find out is the in order will be in sorted order 0, 5, 10, 15, 20, 25, 35, 50, 60, 65, 70, 75, 80, 95, 100. So looks like this is the correct value. Maybe I can also print it here for the pre-order. pre-order is going to be first the value data. Okay, so the pre-order is data first, and then left, and then right. So it's going to be here data is 50, and then the left data is 25, and then go to left, data is 15, and then go to left, data is 10, and then go to 5, and then 0. Now coming back to 25, go to the right 35, and then print the left is null, and then print the data is 35, and then it's going to be 20. Now coming back to this side, in this tree first we need to fill up 75, then go here, fill the data 65, then fill 60, then 70, then 95, 80, 100. Let's check this pre-order data comes first. Okay, so pre-order, data, this should be left and right. Okay, there is a mistake here, sorry. Okay, so left and right, left and right, left and right, looks like good. Okay, let's go back and check. 50, 25, 15, 10, 5, 0, 35, and then okay, right here 35, then 20. Yeah, right. 20, 75, 65, 60, 70, 95, 80, 100. There is a problem here. I'm not sure what happened. Okay, and the post order is going to be post order is L or D, left, right, and then data. Okay, so left, right, and then data. First 50, 25, 15, 5, 0. So 0, left, right is null, then data, right is null, then 10, right is null, then 15, left, right, and data. So right, left is null, right is 20, 35, 25, then goes back to here, left, right, and data. We need to fill 60, 70, 65, right, 80, 100, 95, 75, 50. Okay, okay, 0, 5, 10, 15, 20, 35, 25, 60, 70, 65, 80, 100, 95, 75, 50. Awesome. Okay, there is some issue here which I'm not sure, but pretty much this code works.